So section 12.3. So let's recap where we went with this yesterday. So on yesterday, we can do trig if we are given a point that's on a circle. So draw an angle, you have a point. Once you are given that point, find the radius using square root x squared plus y squared. And then you can find the trig functions. So we did 3 examples of that yesterday, simply taking a point, finding the radius, and then using the radius in that point to find the trig functions. So 3 essentially garden variety examples of that before we transition to the unit circle. So unit circle we use when the radius is 1. So if we have a unit circle, you'll know when you're using a unit circle because the problem is going to specifically say unit circle. So if it specifically says unit circle, we look at the angle, we pull it off of our chart, and then we find the trig functions that go with it. So we did one example in which we did all 6 parts. And then we did 4 more examples in which we just found the trig function that was asked for. And that's what took us up to the end of our time on Monday. So today we do the last part, which is what we would use if we were combining right triangle trig with trig on a unit trig on a circle. And that is the idea of a referencing. That's the idea of a referencing. So, just a side note, those of you who are going to pre-calc honors, I've already asked the teachers that are teaching it this year for a study packet, whatever prerequisites you should know going into pre-calc honors. That way, I'll give you a copy of that as you transition out of the 2 trig at the end of this year. Again, I don't know whether I'm teaching it or, well, I know preliminarily that I am teaching it, but it's not definitively yet. So I want to at least make sure you have that before you head out of there. That way you can actively make sure that you brush up before you start it in the fall. Most of you aren't going to look at it until August anyway, but at least you will have it. So, a reference angle. So here's what is meant by a reference angle. So we're going to look at that diagram that's in the top right hand corner. So if you are given an angle that is drawn for you, remember your initial side goes on the positive x-axis, the other side is wherever it ends up falling. So here you have an angle drawn. So, in order to use right triangle trig, your angle has to be between 0 and 90 degrees. Because that's what a right triangle trig allows you to do. So, if we draw an angle, we can always make a right triangle out of it. If we make a right triangle out of it, we take wherever the angle ended, draw it back to the x-axis, so whatever angle that is, this becomes your reference angle. So the question is, why don't we use that other angle in the triangle? Because it wasn't attached to the origin. That's why you don't use it. That's why it's not associated as a reference angle. It wasn't attached to the origin. So, the main thing here is figuring out how do we find the reference angle? How do we go about finding this reference angle? finding the reference angle is actually not that difficult. Finding the reference angle is not that difficult. It just depends on where it's located. So, there are 5 steps associated with finding a reference angle. 3 of them, the first 3 are simply what to do in case this happens. So we're going to go through all 5 steps, and we're going to use example 9 as our guide. So, step 1. Change the angle from radians to degrees. Change the angle from radians to degrees. So, remember to change from radians to degrees. You take your angle, multiply it times 180 over 5. Take your angle, multiply it times 180 over 5. Now, in the case of example 9, we don't have to change that. It's already in degrees. Step 2. If the angle is negative, find the positive coterminal angle. So, if the angle is negative, then you add 3/6. You want to force it to be positive. Again, for example 9, we don't have to do that. If the angle is greater than 360, subtract 360 to force it between 0 and 360. Again, example 9, we don't have to do that. So steps 1, 2, and 3 are all if that situation occurs. If it doesn't occur, skip it. Step 4, you're going to do no matter what. Identify the quadrant of the angle. So in terms of quadrants, probably learned this in either 8th grade or Algebra 1. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 1 is between 0 and 90 degrees. Quadrant 2, 90 to 180. Quadrant 3, 180 to 270. Quadrant 4, 270 to 360. So you first have to figure out where is this angle located. It's 325 degrees. It's between 270 and 360. So this is in quadrant 4. So that's in quadrant 4. So since it's in quadrant 4, for step 5, to find the reference angle, we follow the direction based off of where it's located. So if it's in quadrant 1, there's nothing you need to do. It's already a reference angle. Quadrant 2, take 180 minus the angle. Quadrant 3, the angle minus 180. Quadrant 4, 360 minus the angle. So since this angle is in quadrant 4, to find the reference angle, so the notation for that is theta prime. So theta prime is equal to 360 minus 325, which is 35 degrees. Now the key thing for a reference angle, your answer must be acute. So that's less than 90 degrees. So you finish the problem, and you find that you have a number that's bigger than 90 degrees, then you did something wrong. Bigger than 90 degrees, you did something wrong, point blank period, figure out what you did. that's that problem. Any questions with example 9? All right. So let's do example 10. So, example 10, same rules apply. So this time we have 16 pi over 9. We have a little bit bigger of an angle, and we have an angle in radius. So now we have to do step number 1. 16 pi over 9 needs to be converted. 16 pi over 9 multiplied times 180 over pi. So remember, when you multiply from left to right. So 2880 pi over 9 pi. Pi drop out. So you get 320 degrees. So first step is to change it over. If the angle is negative, well, it's not negative. Move on. If the angle is greater than 360, well, that's not greater than 360. Move on. Identify the quadrant of the angle. So, once again, to our next little chart, 320 is between 270 and 360. So that means we're operating in quadrant number 4. So since we're in quadrant 4, the reference angle is 360 minus 320, 40 degrees. And we know that we did this correctly, that this is a fair, reasonable answer, because that angle is acute. It is less than 90 degrees. So, that's it. Problem's over. You've done harder stuff in this class before. This definitely is it. Any questions? Example number 10. My group in here, y'all straight? All right, so when you pause, as far as 11 and 12 go, you should have 50 and 70. Should have 50 and 70. Number 11, 50, number 12, 70. So does anyone have anything different than those two? Anything different? If not, then we should be able to knock these out pretty quickly. So, then for example 11, key thing here is you start at negative. So since you start at negative, take your angle, add 360 to it. You're going to force it to be positive. So that ends up being 230. So that's not greater than 360. You don't have to worry about that. So as far as 230 degrees go, your quadrant is 0, 90, 180, 270, 360. 270 is going to fall, the 230 is going to fall right in there. 230 is in quadrant number 3. So your reference angle is 230 minus 180, 50 degrees. So we have our reference angle over here. .470 works the exact same way. And so in this case, 470 is bigger than 360, so we're going to force it down first. So 470 minus 360, 110. So quadrants go. So again, I'm drawing it because it's notes that I'm uploading. Don't draw this unless you absolutely need to. 110 degrees falls in quadrant number 2. So reference angle for quadrant 2 is equal to 180 minus 110, 70 degrees. The one answer is 50, the other answer is 70. Any questions, 11 or 12? Yeah, my kid would probably say, okay, we've done harder stuff in this class than this. So, any questions on finding the reference angle? 9, 10, 11, 12. Again, the hardest part is making sure that you convert it to whatever you need to convert it to at the start, and then using the appropriate conversion for the reference. Other than that, it's pretty self-explanatory. So, stop my report.